Alright, we're live. Hello everyone. Yeah, I had to miss stream yesterday because I have some problem with my heating in the apartment, so I had to fix it. And yeah, today I will continue to learn Rust and Axum with Jeremy Chan course. But before, I want to watch one video from Jayman. It's about static Hermes. This is a meta JavaScript engine that used in the React Native. So curious, what is it about? So
JavaScript is pretty much everywhere, and everywhere that it is being run as an interpreted language. So you'll have JavaScript in the browser, and then you'll have a JavaScript engine, and it takes the text, the JavaScript code, and it interprets it on the fly and runs it in the browser to do what you need it to do. Similarly, in Node has a similar thing with V8 as the JavaScript engine, and React Native has both JavaScript Core and Hermes, which we're going to be talking about in a little bit, which are JavaScript engines that, again, interpret JavaScript code and run it in the engine. What if you could compile your JavaScript to binary native code and run it right where it was without having to deal with any sort of interpreter or JavaScript engine? That's where static Hermes comes in. This was announced by Svetan from Meta at React Native EU in 2023. I was lucky enough to be there and participate in that conference, which was really great. And when I heard Svetan talking about static Hermes, I knew I needed to get my hands on it. What static Hermes does is it takes Hermes, which is a JavaScript engine, and it turns it into a compiler. So it will allow you to take JavaScript code or TypeScript code or Flow if you want to use that. Remember, this is a Meta product, so they're going to use Flow. And it allows you to compile it to native binary code and introduce ahead of time optimizations based on the types that you're giving it. So if you're just compiling JavaScript with no Flow or no TypeScript, then you're not going to get a lot of optimizations because JavaScript's hard to optimize. That's why interpreters are not as fast as native code. If you give it types, then it gets really fast. If you want to know more about how static Hermes works, you really should go watch Svetan's talk at React Native EU. I'll try to link to that in the description here. What we're going to be doing in this video is we're going to actually try to run static Hermes on my machine and compile some.
yeah, probably should look this talk as well, but sure, not today.
JavaScript into a native binary and run it, and we'll just play around with it. This is sort of bleeding edge stuff. I mean, static Hermes is really not ready to go. When I asked Svetan about this, he said, "Prepare to be disappointed." Terrible accent. I'm really sorry, Svetan, but he was like, "This is not ready to go, but you can play with it and let me know if there's anything that goes wrong." I've already downloaded a copy of Hermes by git cloning it here, so let's go take a look. When you think of static Hermes, just think of like the next iteration of Hermes. It's Hermes, which you can interpret, but it's also statically compiled Hermes as well. So it allows you to do both. I'm not going to spend really any time looking through the Hermes source code. Maybe we could do that at some later date, but I just wanted to show you that this is just what you would download from GitHub. So let's back out of there. And what I've done is I built Hermes in two different places, build and build release. Build release is like the tighter, more optimized release mode versus build is the debug mode. So let's try running it first. If I jump into build, you'll see that we have a bin directory right here. So let's jump into that. Not bun. We're not doing bun this time. And if I look in bin, there's a bunch of different binaries here, but there's Hermes, and then there's also Shermes, which is static Hermes. So let's run Shermes. And there it is. It's 0.
It's so funny. So funny name, Hermes. Static Hermes.
4.0, and let's try running --help. And you can see there are a bunch of compiler flags that you can provide, like optimization levels and whatnot. If you're used to things like Clang or CLang or any of those, this will look fairly familiar. You'll also notice here that it can parse Flow and TypeScript and JSX right on its own without having to deal with any sort of transpiler, which is really nice. I also have the sandbox folder, and in this folder, you can see I'm already in it in this VS Code instance that I have up here. I have a C++ file and I have a hello.js. There's nothing in the hello.js, just a comment. And then the C++ file has a little just hello world here. And the reason I did the C++ is because I wanted to show you, the C++ is not needed for Hermes. In fact, it replaces C++. It allows you to write JavaScript or TypeScript. Let's actually compile a little binary with C++. So use g++, world.cpp, and then -o, which is like the output. We're just going to output it to world. And now a new binary file shows up. You can see it's binary. It is about 40K. And if I run that, it outputs hello from C++. So let's try to do the same thing, but with hello.js and static Hermes. So static Hermes does not have console.log. If we try to do this, it will not work. I'll talk a little bit more about that in a second. What it does have is a print command. And if I say hello from static Hermes, what we need to do is this command, which is a little bit funky, but you can see that the -o is similar. It outputs to hello, and we are compiling hello.js. So let's try running that. And now there's a hello. So let's do hello. And there we go. Hello from static Hermes. And you can see that it's a fairly similar size, 40K for the C++ and 51K for the hello from static Hermes. Pretty similar. But we just ran JavaScript code in binary. That's pretty cool. Now, I mentioned that you can't just do console.log. In fact, if I try, let's try console.log, try building again, it says console was not declared in anonymous function. Hopefully these error messages get a little bit better. So we don't have access to console. So you might be asking, well, what good is this? It's not like Node where I can just access everything I need to build. Keep in mind that for the most part, this is going to be used to replace C++ situations. So if you were normally going to write something in C++, that's where you would use this. And it's not going to come with the same standard library that a lot of these other runtimes might have, like Node or Bun, or even living in a browser. Now, I'm hopeful that at some point we'll have connections for all of these things, because I would love to be able to write full-on code here using.
So how we actually debuild it? Is it what the command was? How we did then I did. Yeah, watching some video about the static Hermes is I'm good. Miss the stream yesterday because has some issue in the apartment. My heating was broken, so need wait master to fix it. And now it's working again, and I'm really happy about it. And yeah, have some time today to do small stream. So doing well. Have you done your bread? Was it made already?
Access to console. So you might be asking, well,
so how he did build it?
command, which is a little bit funky, but you can see that the -O is similar. It outputs to hello.
Okay, and here is use Hermes typed build GSI hello Jess. Okay, cool. GSI. Okay, basically we run the Hermes with some commands and it compiles hello.js. All right.
Oh, and we are compiling hello.js. So let's try running that. And now there's a hello. So let's do to just get a little bit better. So we don't have access to console. So you might be asking, well, what good is this? It's not like Node where I can just access everything I need to build. Keep in mind that for the most part, this is going to be used to replace C++ situations. So if you were normally going to write something in C++, that's where you would use this. And it's not going to come with the same standard library that a lot of these other runtimes might have, like Node or Bun, or even living in a browser. Now, I'm hopeful that at some point we'll have connections for all of these things, because I would love to be able to.
Oh, okay. Yeah, that's cool. It's interesting. Yeah, actually a lot of interesting things is going on in Ukraine, like in how to say, in this small business or not small. I'm watching a series of videos about Ukrainian craft business, and yeah, there is a lot of people doing cool things.
able to write full-on code here using static Hermes, just compiling right to native. But again, this is really, it's designed for React Native. That's its primary use case. And those things are actually really, they're defined by React Native rather than by
Oh, yeah. But was it how it was delivered? Is it was already in the United States, like, or it was deliveries from Ukraine? Oh, cool. How long does it take? I actually bought my keyboard from United States and it wasn't too bad. It took 2 or 3 weeks. Oh, nice, nice, nice. There is Ukrainian company Nova Poshta, and it's so amazing. In Ukraine it's so fast. It's like it deliver everything in one day, mostly in most part of Ukraine, and super cool service. And now they expand to new countries, and there is some places in United States where you can buy something and then like order from Amazon to their place and they will send it to me. So it's much easier now to buy something from United States. Not sure how is it in different direction, but yeah. The fermented Remo isn't widely okay. Currently, I see. Yeah, probably they can't do it directly anymore, like, or it could be that it's too costly to make shipping from the Russia or Belarus. So yeah.
by Hermes. What can we do with static Hermes? Well, not a lot yet, but we can rename this to TS. So let's try that, hello.ts. And now that it's a TypeScript file, let's try extracting the keys, object.keys, from the global this object, which does exist. And then we're going to go keys.forEach, and we're going to do print key. And then we simply need to recompile down here. And it did not find JS because I renamed it, so TypeScript. And then let's run hello. And all it found was a promise. Interesting. That's because we really need to do get own property names. That's actually a better option right here. And let's try recompiling and rerunning. And now we actually have a bunch of different property names. So you can't just do keys. That won't work with global this. So this is kind of interesting. You can see things like error and infinity and parse int, parse float. You don't see console here. Set, map, weak map, all these things. There's print. There's also eval, which is kind of interesting. Let's try that. Let's try that. In eval. And we got our first segmentation fault. Hey, how about that? So eval didn't work very well. There's an interesting Hermes internal. Let's see if we can get what's in Hermes internal and see what's in that. Compile that and then run hello. And Hermes internal has concat, has promise, and queue job. get function location. These are kind of interesting. This is not documented. Most of the stuff is not documented right now. This is stuff that I would probably wait on Svetin to release more information about, and the rest of the static Hermes team there at Meta. Let's try a few other things. So let's try doing const today equals new date. And actually, I want to see if we can do string interpolation here. All right, let's see what happens. Today's date is Monday, November 6th, which is actually true as of today. So it did seem to get it. And in fact, if I then run it again, it did change. So it is pulling that date in right now, which is cool. You'll notice that there's a TypeScript error here, expected 0 arguments but got 1. That's because the print signature, which TypeScript expects, is not the same as what Hermes expects. So if I go up here and try to get rid of that, declare function, it appears to work. But if I were to try to compile it, it doesn't seem to like that. Invalid statement encountered. So doesn't like that. I'm not sure how to fix this yet. This is, again, still pretty new stuff. Now, if you try to send this hello to someone else, it's not going to work, because if I cat this, I'm actually going to expand the screen and then cat hello. You'll notice that it hard codes my path in to the binary to the library. And this is basically where it picks up on Hermes and all of Hermes' functionality. So if I were to want to compile this without having that dependency and be able to send it to someone else, what I pass in is the static link and deal with the TypeScript error. And then now if we do an L, you'll see that it's actually quite a bit bigger. It's 22 megabytes rather than like 51K. So it actually brought pretty much all of Hermes into the binary and it's ready to go. But this is not interpreted. Again, this is like bringing in Hermes and adding on almost like a plugin, which is your app. It's like binary that actually runs right there. It's not trying to interpret it. So it is quite a bit bigger, but you can at least distribute it anywhere you want to go. My assumption is that this is going to get much smaller as time goes on and more optimizations are included in this. So that's pretty much all I had for static Hermes today. I'm hopeful that I'll have a lot more for you folks in the future, because I'm really excited about what static Hermes can do. But really where static Hermes is designed to run is in a React Native app and a mobile app. So you can run it in an Android or an iOS app, and it will take the place of where you might write native code, maybe in C++ or something else like that. It allows you to write TypeScript or Flow and just compile that right into your app. The downside, of course, is that you can't do over-the-air updates. And there are some other kind of limitations as well. Huge kudos to Svetin's team over there at Meta, who has put this together. I couldn't be more excited. Anyway, that's enough nerding out for today. I'm Jamin, and please hit that like button, hit the subscribe button. I know I've been putting out a lot of content lately, but I hope to do stuff that's kind of interesting and get you a little bit further along your journey here with React Native and other cool tech that I like to nerd out about. And I'll see y'all next time.
Okay, so far nothing to do with this static Hermes. Like, it's very early stage, and I guess the main goal is to use it in the React Native apps. Maybe something else in mind of Meta team. Probably we will watch at some point the actual talk. I don't know, maybe tomorrow. Yeah, I think Hermes is mostly was developed for the React Native, like React Native running a JavaScript engine on iOS and on Android and maybe somewhere else, and communicate to the native part. And it was more or less okay on the iOS. On Android it was much slower, and then I think Meta team decided to create their own JS engine that can be used on both on any platform they need it, and also to optimize it, not just like take whatever JavaScript engine, but maybe optimize for their need. And yeah, there is already many iteration on it, and the static Hermes, it's something new. It's not released anywhere. Just I think it was just announced on this talk that they are working on it. But yeah, it's kind of one of the biggest problem of React Native. Like you need to write mostly you need to write just JavaScript, but at some point you need to face these places where you need to do something natively, and it should be not just JavaScript but also some Objective-C or Swift, also Android, Java or Kotlin. And if you want to do super fast with new architecture, you might want to mess a bit with C++. So it's kind of too much. And with this static Hermes, I guess you can avoid this piece where you, maybe not all cases, but at least some cases where you can just use JavaScript again and it will be fast as C++. This is, I think this is what the purpose of it, but yeah. This is actually was first video I looked about it. Anyway, yeah, I'm going to back to, okay, it's wrong video. Back to Rust course.
Model layer.
And yeah, continue with model layer. Yeah, exactly. The Hermes itself, like, is JS interpreter, but static Hermes is will compile code to binary.
We're going to do our first task.
Okay, I think we can turn on music.
BMC, which stands for Task Backend Model Controller.
Okay. Task backend model controller. We'll have create, get, list, delete. Okay.
So first we are going to open the model folder, which is our model module. So in this module, we have our own error, and we are re-exporting the error and the result alias as a module error and result. So we are following our best practice. And then we have the model manager. So in the Rust Axum course, I call that model controller because I merge the two. In this code base, we're going to split. The model manager will have the states, and the model controllers will be the construct that does the access to the different model entities. So the design is as follows. The model layer normalizes all application data types and access. All application code data access must go through the model layer. The model manager holds the internal states and resources needed by the model controllers to access the data. So for example, the model manager will hold the database pool, the S3 client, or the Redis client. So the model controllers like task BMC, project BMC, which is for backend model controller, implement CRUD and other data access methods on a given entity, task, project, and so on. Every access starts with a main entity first. And so the BMC, as I've said, is short for backend model controller. Because when we do a UI, we're going to have the mirror of it, which is going to be the front-end model controller. It's going to be much simpler, but it will allow to expose that to the front-end. And then in frameworks like Axum or Tori, the model manager will be used as app state. So there's one model manager, multiple model controllers. And so the model manager are designed to be passed as an argument to all the model controllers functions. And we're going to see how we can protect the visibility of those resources only to the model layer. So now that we have this overview, and we're going to go to our model manager, and our goal will be to add our DB, which will be our database pool connection. So before that, we're going to have to do some work, but that is a goal. And then in the new, this is where we're going to instantiate the database pool connection to set it to the model manager. So to create a new database pool, we're going to create actually a little layer. And this one is going to be very simple for now. It's going to be store. And we're going to create it as a mod.rs because eventually that can grow bigger. So now it's just
Okay, mod store and create as mod.
the store. Since it's a mod.rs, we're going to have our code region modules. We're going to have an error. We'll create an error. It's going to be a very simple one. And I have a little code snippet that creates a whole boilerplate like that. So the design of the errors that I follow is they are based on enum and they derive debug at least. And the reason is because the toString, this is going to sound a little bit weird at the beginning, but actually there's a big reason for that. The toString, which is I'm implementing display, just format the debug format. And the reason of it is because all of the backend server errors are going to be logged as a request log line, and usually that will be a JSON format, a new line JSON. So I do not need to have human-friendly text, so I'm going to make sure that the enum variant name and properties, if there is, are going.
I'm actually curious. Is it there a better way, like creating a lot of this boilerplate errors? It's kind of the same. Do we really need it? Like we have error in the model, in the store, in the main, in the web. Oh, this is yeah, here we have some extra logic, okay. It look like makes sense. And this is like boilerplate.
Going to be very self-described, such as I don't have to reformat the message because anyways the serialization of these errors will be in JSON. So that is why I'm following that for backend services. Now for command line, I like to use this error because it's very convenient to do formatting. But for Story or Axum web backend services, I usually go with this model. And so then what I do is that my error implements CLI from CLI. And this is again, it's because I am in the backend, and it's not because I'm sending this error to the client, because you do not want to send them to the client, but it's because I want to log them in a new line JSON format, because it's very flexible, and then I can push them into a CloudWatch or another log services. And obviously at the end, we don't forget to implement the error trait for our error, such as we can use a question mark nicely. So now that we have that, we're going to add one error on this one. It's going to be very simple because we're going to use mostly SQLX and then later SQLB. So the store layer in this first episode is going to be very light. And the first error would be fail to create pool. And in this case, I decided to have the string, which is a toString from SQLX. I could also have.
Okay, so have failed to create Pool string.
To have the whole SQLX object over there, that would be completely fine as well. And then to follow my pattern, I will export the result type alias on this error. So like that, when I go back to the store mode.rs, I can re-export this error and this result for this module. Now on this one, we're going to use our config crate, because that is the whole point, because we're going to have our DB URL in the config, and then we're
I'm just keep thinking if we can reuse all of this code from boilerplate. Or not. Okay, not sure yet.
we're going to use SQLX, the pool options, the pool, and the Postgres. So first, we're going to define our type alias, db pool Postgres.
Okay, we're back to the store and do use pub actually pub use self error and result. And then pub type db
So now in the config, we do not
pull from SQLX and Postgres. I think we did something init db devdb. Yeah, we did it already here, but it's like only for development purpose.
do not have yet our DB URL. So we're going to bring our cargo to ML, and we're going to organize our code as if it were on Kubernetes. So we're going to have a section for secrets, which in Kubernetes will go to a secret config file. And this is an important point. The keys and the passwords that we have here are just welcome type of passwords. They are not passwords that need to be encrypted. We don't have to have all of this complexity, because in a deployment, that will be managed by the container, Kubernetes or KMS or whatever on Amazon. But in our case, in a local development, all can be welcome. So we don't need to encrypt or have fancy scheme here. We can just put our service DB URL like this one, and that would
So this one, right, app user, dev only password, and put it in the config, right? Config. This is secrets. pg dev app URL. Okay. I like this cargo config. I'm actually doing something similar in my NeoVim plugin, but with a JSON, since I came from JavaScript world, and this was analogy for package.json at some point, but maybe cargo approach is nicer. So I can just have environment, like I also have here environment, but I put the file path, which is more convenient for me right now. Okay.
It would be our app user with our password. And then the only reason why I have dev only PW rather than just welcome is because I don't want both to use the same password, such as I make sure that my dev util codes kind of make sense. That's the reasoning behind. Now that we have that, we can bring our config, and we're going to have a DB URL, and you guessed it, in the load from env, we're going to add.
So config something like this. Okay, yeah, db URL string and service db URL.
The reasoning why I have
Service. I
that
need
would be our
to follow it. I need service db URL, right? Okay. The caps lock is usually destroy my Vim experience. Okay. There is no typo, should be fine.
and you guessed it, in the load from env, we're going to add db, get env, service db URL. Everything is becoming very simple now. And we still have our prefix before, such as we know what comes from us, but sometime in the Kubernetes or in the Docker scenario, you will have other environment variables that might not have this prefix that you still want to have. So you cannot assume that all of your environment variables will have such a prefix. Okay, so now we can go back to our mod.rs, can create a new DB pool that will return a result of DB, and that will be a new, our max connections, and our connect, and we can use our DB URL. Now for the max connections,
so this is our store module, and we want pub async, and new DB pool, result, and DB, pg pool option, new max connection 5, connect config DBRL. Okay. And I think we need await. No.
we could have put that in an environment variable, and actually a good strategy will be to put that in the config even if it's not in the environment variable. That is a good strategy as well that I like to have, and this will be a good improvement for later. Then obviously that is an await, and then we're going to map the error into our fail to create pool error.
Okay. Map error. Failed to create pool.
Error. And in this case, we are going to do a toString because we need to serialize, but it's actually we're going to see later that SQLX implements display, and there is a macro that we can use as well. So, but this one, we're doing it manually and it works fine. So now we can go back to our model node.rs and we can implement this one, import the DB from our store DB, and then in the new, we're going to do let DB new DB pool, type would match, await question mark, and now we can do our model manager and we put the DB.
No.
We're going to press save, and here the question mark is going to have an error. error because the new DB pool is a store error and the result is from the model layer. And so to resolve that, what we're going to do is we bring our model error and we're going to implement the variant and the from for the error. So the way that I like to do it is I have a little section like that say all of the modules that I want to wrap, and I put a store, and I do a store, I import it, and I do error. So like this,
Interesting. So we do modules and do store error. Use create. And we need to map error, I guess.
I see clearly what type of module I'm using in this error. Then what we need to make sure that the Rust compiler can go from the DB error to the model error is to implement our froms. So I put that in the code region where I'm going to put all my froms, and I have a little code snippets where I put the store and the variant is store, and that's it.
It made different way, so we can implement from store store error, sorry, for error. And what we do, we return error store wow, right. Keep it down. Okay, we do self. So, and this should allow us to automatically convert, right? So like we shouldn't worry about mapping here. And it's still working, right? Oh, nice. So this is type converting. Trade from. Nice. No, nothing in the Rust book about the from trade, Rust from trade. Used to do value-to-value conversion while consuming the input value. This reciprocal of into. One should always prefer implementing from over into because implementing from automatically provides one with implementation of into thanks to the blanket implementation in the standard library. Only implement into when targeting version prior to 1.41 and converting to a type outside the current crate. From was able to do these types of conversion in earlier version because of Rust or funny rules. I think there was into. So maybe just too small. Search term just to be longer. Once the teacher value-to-value conversion that consumes input value, the opposite of from.
That's it. So there's some macros and annotations that you can add that will do that for you. But in my case, because I have these little snippets, the overhead is relatively low, and I like it because I have the full control. But again, this is more kind of a personal preference. The important point here is to make sure that you have the right error structure, that the right module has the errors that they need to have, and that they cascade back up correctly. Okay, so now that we have that, we have a little question mark that is resolved over there. So that basically is our constructor that returns the model manager. So now what we want is to expose the DB, the database pool, only to the model layer and we want to have the new accessible to other modules such as the main.rs. So the way we're going to do that is we're going to do a pub in create model, which is going to be a function DB, which is going to return a reference of DB. And so this in
pub in create model db self
create model restrict only to the modules that are below the model. And then the function new is accessible to all of the code base that have access to Model Manager. That is a way that we're doing it. It's not like a developer cannot make a mistake, obviously, but at least here we are putting the right constraint in our code, such as it's very intent driven. Only the model layer needs to access to the store. So that is a way to accomplish that. So in short, that returns the SQL XDB pool reference only for the model layer. So if we go to main now, we have our model manager new, and that still compiles. But if we were going to do a db equal model manager db, that will fail. And if we mouse over, we get db spotted. That is pretty neat. We're going to remove that. And now we're ready to create our task model controller. And we're going to create our pub mod task, and that will be a single file. That is enough for now. And usually this model controller are more on the leaf side, so they don't need their mod.rs. Having just a file is enough. They will use the model errors. But obviously, if you get more complex, you can have a next level of hierarchy. So we're going to use the model manager, we'll use the model result, and then we're going to use the CRD serialize.
Okay, let's create did we create model like mod task, pub mod task. Okay, so model mode and pub mode task.
That is their mod.rs. Having just a file is enough. They will use the model errors. But obviously, if you get more complex, you can have a next level of hierarchy. So we're going to use the model manager, we'll use the model result, and then we're going to use the CRD serialize and deserialize. And it's a from row that will allow us to read the data from the database with SQLX and to translate it into a struct. So that is a convenient way to get a struct from a PG rows. And eventually we're going to have more dependencies, but at least that is the beginning. And then we're going to have a code region for task types. So typically I like to have my types at the top and in their own code region. Often you write them at the beginning and then they evolve less than the behaviors. So that is the way that I split the code. So the first type is going to be task, and that is what is going to be sent back from the model get and list and so on. So it's going to be our pub ID I64 and a pub title string. string. It's going to implement debug, clone, and then from row, because that will come.
Okay. So we'll have a pub struct task and then pub id i60 for pub title, which will be a string, and then we want to derive, clone, debug, and from row. And from row where we did get this. Yeah, Skrillex exactly.
And a pub title string. It's going to implement debug, clone, and then from row, because that will come from a SQL query. And then finally, we need to implement also serialize, because when we're going to do the APIs, we will serialize that into JSON. And then we're going to create another type, which is going to be our task for create. And this type is...
Okay, I need to... Berber into min. And I'm back. All right.
is when we have the APIs that want to create tasks. So here is very important. The concept of
struct task for create, and I guess we will have only title here.
of this design here is that struct are views on.
Yeah, it should be serialized. Or maybe deserialized. Serialize it. No? Yeah. Okay. I think there should be deserialize.
On your database tables. They are not the exhaustive representation. Sometimes you might have things in the tables that are not the business of an API, and oftentimes you want struct that are only a subset of what you have in the database. So for example, for task for create, you don't want to have people being able to reset the ID of a task, or you do not want an API to be able to reset the creator ID or the modified time or the creation time of an entity. So that's why you are splitting these things into what gets read and what get pushed. So in this case for create, we are deciding, just in this example, that you must have a title. And so we're just going to implement deserialize because that is going to be something that is going to come in. And now similarly, we're going to have a task for update. And that is when we are updating an entity.
Task for update. So I guess it should have ID and option, no, title, right? Option string. Also, at least it should be deserialized. Oh.
Entity. And right now it's going to be a little bit silly, but it's just going to be the title option of string. So on this one is also need to implement the deserialize. If we look a little bit at our three types, we have the task, and that is what gets sent back from the API, from the model layer. And then we have the task for create and task for update. That is things that are sent to the model layer to update the data structure. So because of that, only task needs to implement deserialize, and task for create and task for update.
So I'm not sure, but I think we need ID because how we know what we're going to update, but let's comment out it for a bit.
Implement deserialize. Okay, so now that we have that, we can start implementing our task backend model controller. And the design pattern is relatively simple. It's going to be a struct task BMC, and it's going to have no property for now. And then we're just going to implement as BMC, and we're going to implement our CRUD. But we're starting with CRUD, but eventually you can have any kind of method. So it can be very specific to the entity. So the goal here is to have the entity BMC being specific to what they need to be, and then we're going to see how we can share implementation between BMCs. So the create is going to be relatively simple. It's going to return a result of I64. So by design,
function create and return result I64.
what we want is that the create is very granular. It doesn't have to return task back. So we're going to make it very efficient, and it's just going to return the ID of what has created. But it's going to take the CTX, which is part of our create CTX, and then
So or maybe I should just go to the source code. GitHub. Text. Use create model. Okay. Use create model. Error and result.
Turn the ID of what has created. But it's going to take the CTX, which is part of our create CTX, and
Thanks.
and that is the user information of who is requesting this action. And so the web layer is creating it in the case of a web application. But the point here is that the CTX is decoupled from the framework, from Axum or Tori or whatever. So this way, once it's in the model layer, it doesn't have to know how the request was made. It knows that it can always expect a CTX, which will have context information needed to make sure that the action can be performed. And the ultimate goal of the design, which is going to be in future episodes, is that you put the security layer at the model layer, not at the web layer. This way you can reuse the model in different type of services for job services or web services or whatever. And then the web layer is just about authentication, creating the CTX, but then privileges and everything is at the model layer. So that really simplifies a lot of design down the road. And so this is why we're putting that early on into the system. And then we're going to have our great model manager, which will shorten by MM. And then we're going to have our tag. Task C, which is our task for create. Now the city.
Yeah, makes sense. Task C task for create.
CTX and the model manager, those are going to be in all of the BMC functions. And then you have the function specific, in a way, arguments, which is in this case, the task for create. So then in the create, it's going to be relatively simple. We're going to get our DB, and we can do that because we are within the model layer. That will return our DB pool. And then we're going to have our let result, and we're going to call SQLX, and we're going to do a query as, and so that is the way it works. And we do a I64 tuple, and we're going to give our SQL here. So insert into task, title, and the values which we parameterize. And we're saying returning ID. So another best practice that I always have.
Okay. First of all, let DB or DB. Oh, yeah. And then into SQLX query S. I'm not sure what does this comma mean, but yeah, let's back to it after we implement the function. So in here we do query insert into task, insert into task, title,
I never do raw SQL. It's always prepared statements. So at least that is a nice protection that you get almost for free from prepared statements. So our returning ID mapped to the I64 that we have over there. So that is the way that SQLX works. You have another generic here that you can let Rust infer. So that's why we're putting the underscore. So now that we have that, we can do a bind task underscore C, the title, and then you are going to do a fetch 1 DB. And at this point, Rust has enough information to infer.
task C, title, and fetch 1.
That we're using Postgres and so on. So everything will be compiling nicely. And then because it's the future, obviously, we are going to do a wait and a question mark. And here, here we guessed it, in our model error we don't have the SQLX, so we're going to add that right now. We're going to add a section, we're calling it externals SQLX SQL.
Externals, and what we're doing here is SQLX. And I guess we do also from. Let's see.
SQLX error. And now the trick is we do not have serialize for SQLX error. So we could use the technique that we use, the toString, and have a string over there. But it's actually, there's a pretty neat one. So we can use with our seriAs annotation and display from str. And seriWith is
SerDWith SerDS and display from str.
is really awesome, so I really strongly recommend it. So now we can do a seriAs annotation, which has to be before the serialize. And then what you do is you add an annotation to the SQLX, which is a seriAs, and we do a as display from str.
Okay, we need to do following. SerDS here, and then here we do SerDS, right, as display from string. And s equal string. All right, we are good.
And then you pass the error. So SQLX error implement display and from str, and so that allows then the seriAs to be able to do the right thing here. So now that we have that, can go back to normal, and we're just going to implement our from, which is going to be from SQLX error to SQLX. And then that's it, we're done. Now that will solve this error.
Yeah, it's solved.
And so now the cool thing is anything that comes from SQLX is going to be managed by our model layer. And now one of the things we can do is our result over there, RES, is actually a tuple of I64. So what we could do is destructure it and just having the tuple that will do ID like that. ID is just I64.
Okay, so this is just something also here, but we don't care about it. and the res ID. Yeah, and what we do, just do OK res ID.
Which is what we wanted. And so we can just do OK ID. And that's it. We've done our create. So now let's go and create some unit tests. It's always good to start early with a unit test, and you don't have to stress too much about having high coverage. It's more about doing some is much better than doing none. So at the beginning, anything that helps, you just do a unit test for it, even if it's not perfect. And then after you clean them up over time. If you do that early, it's going to speed up your development because it's actually a good cues on things that works and doesn't work. And it will also make your code much stronger. And when it's time to add more unit tests because your code is more mature, it's going to be much simpler. The same way here, I have a code snippet that create the snippet. I'm using allow unused, but that actually you can remove it. It doesn't really useful in this case because we already have it as a module. I always use super of stars, and then I like to use anyhow, such as I don't stress too much.
Okay, let's do the test, and it's quick test mode tests. So we do allow, not okay, not like this. We do allow unused, but it should be in the square bracket. Alright, use super and use anyhow result. Use anyhow. Yeah, it's so cool with Rust. You could, so easy to drop test right near the Axum function. I don't know, I feel good about it. The amount of time I spend in JavaScript ecosystem, I need to configure this all stuff. Like, I don't know, maybe it's not everywhere, but in the React Native, I'm doing a lot of setup just for write first test, and here you could write your test right away. You don't need to set up anything, almost. This is cool.
Errors. So now I have another snippet here to add a Tokyo test, and we're going to
test name. Okay, sync test name and result unit sync function Tokyo. Oh my gosh, I do so many typing. I probably, yeah, need to finish my stream right after finish with this test part.
go to test, create, OK. So the convention.
Okay. Test, create, OK.
That I like to have is I always prefix with test underscore. That is optional, but I usually have the function that I'm creating, and then I add the suffix OK. And then if I have different tests on the same function, I'm going to say OK simple, for example, and OK double create, for example, to make sure that I can narrow to only one when I want. And then for the error, when the test needs to check if something failed, the convention that I follow is I put a error underscore something, or I just put a error. And right now, because we have only one test create, I'm going to do a test create underscore OK. Now that we have that, we are going to do the setup and fixtures. And for that, we are going to want to use our dev util, and it will be nice to be able to use something that will return a model manager. And right now, the init dev doesn't do that. So if we bring our init dev, we see that it doesn't return anything, which is what we want because we are calling it from main.rs and we don't want to create an extra model manager. So what we're going to do is create another function.
Okay, I think I want to stop at this point. I feel like I need a bit break because it's become too hard to follow what is going on in the video. So yeah, thank you for watching. Eldin, if you're still here, thank you. Have a good night. Yeah, you too. Have a good weekend. Bye.